Hello everyone, my name is Vaishnav Kurade and today we are going to learn about MIPS32 assembly code layout and assembly directives. So the content of this lecture is MIPS32 assembly code layout and understanding assembly directives. So let us begin with the MIPS32 assembly code layout. So first of all, what is MIPS32? MIPS32 is a reduced instruction set computing used in many embedded systems. It emphasizes simplicity and efficient use of resources for better performance. So the basic syntax structure. The basic syntax structure includes section for code, that is dot text, and data, that is dot data for data declaration. Comments can be added using the hashtag symbol for clarity. Each section plays a specific role in the program execution. So here on the left side, we have a basic code layout. So as you can see, there is the dot text, which is for code section, dot global, which is for starting point, main. In main, the user program goes here. Dot data, this is for data section, and user program data goes here. So let us understand the basic code layout using an example. So the example here given is about add two numbers from memory and store the result into next memory location. So let's break down the code. So first of all, the dot text section. This section contains the instruction that will be executed by the processor. Then there is a dot global main. This declares main as a global label, making it the entry point of the program. So main, the label defines the beginning of the main function. So the first instruction is the load address instruction. The load address instruction loads the address of the value label into register $T0. This makes $T0 point to the memory location where data is stored. Next is the load word instruction, which loads the word stored at the address in $T0 into register $T1. Specifically, it loads the first word from value into $T1. Similarly, the next instruction, and then there is add $T3 comma $T1 comma T2. This adds the value in $T1 and $T2 and stores the result in $T3. Next is the store word instruction, which stores the value in $T3 at the memory location $T0 plus 8. This stores 80 as the third word in the value label data section. So dot data section. This section contains the data values that will be used by the program. So the values are 50, 30. So the addition of 50 plus 30 is stored in $T3, which is 80. So next, let us understand about the assembly directives. So what is the purpose of assembly directives? Assembly directives, also known as pseudo operations or pseudo ops, are instructions used in assembly language to guide the assembler during the assembly process. Directives are commands that control the assembly process but are not part of the actual program execution. They help in data organization, memory allocation, and defining program structure. They don't translate into machine code directly, but provides the assembler with information about how to structure, organize, and allocate resources in the program. So the importance of directives. Proper usage of directive enhances program readability and maintainability. They provide necessary details to the assembler about how to interpret the code. So let us see some of the common assembly directives. So first one is dot text directive. So dot text directive marks the beginning of the code section. It tells the assembler that the subsequent lines contain executable instructions. Second one is dot globe directive. The dot globe directive declares a symbol SYM as global, making it accessible from other files. This is crucial for linking multiple assembly files together seamlessly. Third one is data directive. The data directive defines a section where all the data items are defined. Variables and constants can be declared here for use throughout the program. Next one is dot word directive. The dot word directive allocates memory for one or more words. It can be used to initialize variables with specific values during assembly. Stores the specified 32-bit numbers in successive memory words. So some additional directives are ASIC str directive. The ASIC directive stores the specified string in the memory in ASIC code, but do not automatically null terminate it. The strings are enclosed in double quotes. So next one is ASIC Z str. The ASIC Z str stores the specified string in the memory in ASIC code, but it null terminate it. And the last one is dot space directive. The dot space directive reserves a specific amount of uninitialized memory space. This is useful for dynamically allocating space without initialization. So let's see the summary of directives. So the key takeaways are: assembly directive facilitate better organization and control of the assembly process. Familiarity with these directives is essential for effective MIPS 32 programming. So here are some best practices. Use comments alongside directives for clarity and maintainability. Organize code into distinct sections using directives to improve structure and flow. Thank you for watching.